Hello everybody, this is the example Ferris wheel video project that I made, and I made it using Google Slides. So let's start it off. So I am doing the electric shock wheel for my example, which I made up. It's my blueprint number 10 here by Mr. Kokotovich. That's me. All right, now let's start with our description here. So we started with our description on this problem. So the electric shock wheel needs to be close to the ground to have access to electricity. The minimum height of a rider is 0.5 meters, and the maximum height of a rider is 15 meters. It takes a rider 6 minutes or 360 seconds to rotate one full rotation. Now, the first thing I want to do is kind of get some of my specifications figured out. So I want to find my max height, my minimum height, the speed, and the loading level. And a lot of these things come straight from the description. So the first thing, the minimum height of the rider is 0.5. That can go right under the minimum height. The maximum height of a rider is 15 meters. That can go right under the maximum height. And it takes 6 minutes or 360 seconds to rotate one full rotation. That's our speed, 360 seconds. Now the loading level, though, I'm gonna need both the minimum height and the maximum height right here, because I know that the loading level is right in the middle of the min and the max heights. So I wanna find the average or the middle. And to find the average, you just add them together and divide by 2, and that gets you the number right in the middle. So my loading level here is 7.75 meters. Okay, from the specifications, let's start talking about the diagram here. So I have my important 4 numbers right here, and I want to think about this. A few of these are, again, straight from the specifications. So the maximum height is 15, the loading level is 7.75, and the minimum height is 0.5 meters. So from the diagram, we can now start thinking about our equation, amplitude, period, and vertical shift. Now, let's see. The period was already given in the specifications as 360 seconds. That's the length of one cycle. Now, the vertical shift is talking about how far are we moving the middle of this Ferris wheel up. And we're moving it from the ground zero up to 7.75 meters. So I know that's going to be a positive 7.75 meters vertical shift. Now, the amplitude here is a little bit more work. The amplitude is the radius length. So I got to figure out from 7.75 all the way up to 15, what is that length right here? What is the length of the radius? So I know that I'm going to do my maximum height subtracted by the midline, because that will give me this distance right here for my radius. So 15 meters minus 7.75 meters is equal to 7.25 meters. My amplitude and my radius are both 7.25 meters. Now I'm ready for my equation. And my equation, I know generally that the radius is, or the amplitude is what is being multiplied out in front of sine, and that the midline or the vertical shift or the loading position is what we're adding at the end here. So I know that my amplitude is 7.25, so I should go right in front. And my midline, my loading position, or my vertical shift, 7.75, should be what we're adding at the end. That's my equation right there. Okay, so now that I have the diagram and these 4 things, let's go on to our graph right here. Now, I've got my 4 things from the description right up on top. I know I want to mark my max, my min, and my midline. So I know that's given. My max is 15 meters, my midline is 7.75 meters, and my minimum is 0.5 meters. Now, for the x-axis, though, what do we put in these green dots, green dotted boxes? I know that my total speed is 360, so I know I'm going to put a 360 right there, but I want to find out what is half of 360. Well, that's 180. That's going to go right here. What's a quarter of 360? That's 90 seconds. That's going to go right here. And then what number is in between 180 and 360? What is this third thing right here? That's going to be 270 seconds. So let's fill in what I have right there. 360 as the total, 180 as the half, 90 as the quarter, and 270 as the 3/4. Okay, I think we're ready to start our graphing right here. So at 0 seconds, when we first begin the Ferris wheel ride, my rider is up here at 7.75 meters. So I should put a dot right there. At 90 seconds, my rider will have gone up to the maximum of the Ferris wheel. That is 15 meters tall right here. At 180 seconds, we'll be back down at the midline here. So that should be 7.75. And at 270 seconds, we should go all the way down to the minimum height, which is 0.5 meters. And at 360 seconds, we'll be right back up at the midline. So now that I have these 5 points made, then I can put a curve right here to it. And that's it, everybody. I've completed this example video project. Thank you for watching, and let me know if you have questions.